The Earth is a water planet, but global water resources are under attack. From dead zones to acidic oceans, vanishing groundwater to rerouted rivers, our water planet is changing in ways that threaten us all. The good news is, solutions exist, and Earth Echo is on an adventure to find them. I'm Philippe Cousteau. Join me as we explore how the most precious resource on Earth is driving some of the most exciting innovations in engineering on Earth Echo expeditions, Water by Design. From space, our planet looks like a watery place. At this distance, one could think that the blue water is a never-ending resource. But we know that's simply not the case. The fresh water that we rely on for drinking, farming, and healthy ecosystems makes up less than 4% of the planet's total water resources, and scientists have discovered that climate change is reducing access to water resources in communities across the globe. The Earth Echo team and I have traveled to Southern California, where a severe drought has impacted some 25 million Californians and 3 million acres of agricultural land. We're exploring the solutions that have been engineered to safeguard available water resources in this particularly vulnerable region. Now, before we can explore how to manage water in Southern California, we have to understand the source of that fresh water. And to understand those sources, we have to look up to the sky. I'm meeting with Kat Borman, a climate scientist at NASA's Jet Propulsion Laboratory. Now, Kat uses some amazing technology to predict how much fresh water will be available for cities like Los Angeles from year to year.
I'm working on a project called the Airborne Snow Observatory. And so what we do, we have a plane with a couple of instruments peeking out the bottom, and we fly over the snowpack in the Sierras in California and in Colorado, and we scan the snowpack and we figure out how much water is up there.
When people think snow, they think skiing and recreation. But when it comes to water here in Southern California and in many parts of the world, snow is essentially a frozen reservoir.
That's absolutely right. It's nature's natural reservoir, sitting up there, collecting over winter, and when the spring and the summer hits, then it comes down and feeds our crops and ourselves when we need it.
Tell me a little more about the instrumentation, how it works. How are you able to have machines on an airplane flying over the ground with snow on it, and you can tell how much snow is there, how thick it is, what's the density? I mean, that's like magic.
I'll tell you the secret. There's 2 instruments on board. One is a LiDAR, which is basically a giant laser pointer.
Okay.
It shoots 2 pulses down, and it measures the time when it hits the ground to when it comes back. So we know how long it took to get down there, and we get a representation of the surface. So we do that during snow off, when it's just the ground, and snow on, when we're measuring the top of the snowpack.
So then
we can subtract the 2, and we get snow depth every meter.
So you said there are 2 instruments though. So there's a LiDAR, what else is there?
There's a spectrometer. So the spectrometer looks at how bright the surface is. So it's looking for the snow in itself, but it's also looking how bright the snow is. So things like dust depositing on the surface, algae we saw this year. So it tells us the albedo of the snow, which tells us how long it's going to sit there for. If the snow's got a lot of dust or algae on it, it's darker, it absorbs more solar radiation, and then it's going to melt quicker.
Of course. Is there a general concern about these kinds of issues or what's happening with snowpack?
Yeah, there's a general concern. A lot of the population gets its water from snowmelt, and so any changes to that, timing or magnitude, is going to impact us. And so if we can get a heads up on what might happen and how might that happen, that's really going to help us plan for the future. Using NASA technology to predict water availability is an amazing first step in better management of water resources. But how does snow in the Sierra Nevadas, more than 300 miles from Los Angeles County, make its way all the way down south to support the freshwater supply of the nation's second largest city? Marty Adams, Chief Operating Officer for the LA Department of Water and Power, met me at the confluence of the Los Angeles Aqueduct
to show us the role engineering plays in importing water to the desert climate of Los Angeles, he also showed us some exciting new ideas they're developing to conserve as much of it as possible. Marty.
Yes.
We're really excited to be here. I live here in Southern California, Los Angeles. I have never seen the aqueduct like this before.
Well, this is pretty incredible. What you have here is the very southern end of the Los Angeles Aqueduct. And we have the second barrel here and the first barrel right behind us. First one completed in 1913. This is the completion of a 330-mile trip for this water down from the Eastern Sierra down to Los Angeles.
1913. That first one was completed in 1913.
Right.
So over 100 years ago.
Over 100 years ago. And this was completed just before 1970.
That's pretty impressive. So it makes me think. Tell me a little bit about the history. I don't think people appreciate the engineering feats and the history of the aqueduct that feeds LA so much of its water.
Well, you know, back in the 1900s, LA was about 250,000 people, but there was really no water supply locally. And so there was a real move to grow large cities on the West Coast. So William Mulholland at the time looked north and found a water supply in the Owens Valley and appropriated water rights for the city back in 1905, and they brought that water, constructed an aqueduct over a number of years, brought that water down, and that's what allowed Los Angeles to be the second largest city in the country.
So over 300 miles this aqueduct is bringing water.
Right, initially it was about 250 miles to the Owens Valley. It's flowed here all the way by gravity. Not a single pump. We actually generate hydroelectricity all the way down. So this is actual clean water with green energy.
How much water is flowing right now?
So we're seeing last year's snowpack still. Right now, in this barrel right here, there's 320 CFS, which is about 2,400 gallons a second. So that would fill a home swimming pool in about 6 to 7 seconds.
Right.
And it's doing that 24 hours a day. It's been doing this for months since the snow started melting up in the Eastern Sierra.
Where does all this water go?
So this water from here is actually going to go under the 5 freeway and into our filtration plant complex. And there we treat the water, make sure that all the impurities are out of the water, bring it to drinking water standards, and we then distribute it to the city. 75% of it all by gravity.
Amazing.
That's quite an achievement.
And this water started its journey as snow in the Sierra Mountains.
Yes, it started as snow. It's remarkably clean, fresh snow melt.
After the fresh water has made its long journey from the mountains, it must be stored in various reservoirs. We walked to the Los Angeles Reservoir that holds around 3 billion gallons of water. There, Marty explained one of the Los Angeles Department of Water and Power's newest conservation measures. So Marty, transporting the water is one thing. Storing it is also a critical part of the steps needed to provide water to a municipality like Los Angeles.
Yeah, that's right. And so, you know, we have the water supply coming down the aqueduct and we treat it, but then people don't use it at the same rate all the time. Obviously at night, you know, the demands are down. People wake up in the morning, they expect to have a lot of water come out of their faucet, water their yard, you know, do the laundry, everything else they need. And so water has to be stored. So what we have is both large bodies of water where we store water in large reservoirs, and also we have small reservoirs. And so this is one of the large ones for us. This is Los Angeles Reservoir.
It's enormous.
Yeah, it's enormous. It's about 3 billion gallons of water. Wow. And it's a little over 150 surface acres. Not a lot of small cities have a reservoir like this, but big agencies or big cities would have a large body of water. So our average water demand is close to 500 million gallons of water a day. So that's the average over the whole year. It'll be more in the summertime and less in the winter, but it's close to 500 million gallons of water every day that we have to serve. So it's a lot of water that goes through the system, goes through the filter plant, and out to the city. So you know, to do that, if we had even an outage for a day or something happened at the filter plant, we have to have a lot of water in storage just so there's no interruption in service to the customers.
And what are these? What are you holding in your hand?
So on this reservoir, we've actually done something unique. We've actually put floating balls on the reservoir. This is called a shade ball, and it's actually made out of a kind of plastic, the same kind of plastic that you'd get in a 1-gallon milk carton.
Okay.
But it's got carbon black, so it's stable in the sun. And what this does is it keeps the sun off the water. It also helps keep the birds off the water. It's not a solid cover like a smaller reservoir might have, but it does protect the water quality and stops algae growth and a lot of things. It makes the water a lot easier to disinfect one more time on the way out of the reservoir.
Leaving the reservoir, I considered how much the people of California have invested in moving and managing fresh water. While importing water from far away is certainly an amazing feat, it's very expensive and can be unreliable. Many communities around the world cannot afford to import adequate fresh water to sustain themselves. So resource managers in Southern California are implementing new and innovative ways of providing water in more reliable, energy-efficient, and cost-effective ways. To learn more about freshwater resources and find ways to take action in your own community, visit EarthEcho International at www.earthecho.org.